it's not just going to tell you what it thinks the most likely next scenario is. It's going to tell you what the candidates were and how close that contest was.
Mm-hmm. And could that information be then reinforced back into the model for, let's say, another, probability problem set?
Oh yeah. Like the Bayesian kernels, what they do, they kind of almost act like a detective that has an initial gut feeling about something. Then as it gets its data and starts refining that gut feeling of, okay, now given this next piece of information, I think we're heading in this direction now. And this one option is less likely. And so it kind of like starts forming these information-based gut feelings that gradually get reinforced. And that's actually, it's interesting because that's kind of how the mechanics of a full-on Bayesian model works.
Hello and welcome to Theta Way Podcast. I'm your host, Jacob Holland, who I am an neuroscience enthusiast as well as an avid knowledge seeker. Here I have an AI machine learning expert who is my co-host, Ryan Reed. Ryan, tell us what we're going to be talking about today.
What is with this new attitude I'm getting from you?
I feel like, I'm like an announcer. I'm like a host, I'm trying to get into like the whole host thing.
It's just like really stiff. So we actually have some interesting stuff coming up today. One,
my bad.
We are going to be trying out our new format that we talked about last time, where we are not only going to be doing our research paper halfway through like normal, but we're doing three
research papers.
Yes. Well, we're covering three research topics. Yes.
Oh,
so we are going to be going over a machine learning topic every week, trying to delve into a complex topic, whether it be fundamental or whether it be an overall architecture based thing, and kind of trying to make it understandable and reveal the mechanics behind it. And then we are going to also be delving into a neuroscience topic every week.
Yes.
And that's going to be run by Mr. Jacob over
I'm going to be going over that. I'm actually really excited. I'm going to be going over the thalamo-cortical system, which is responsible for generating your conscious experience.
So, whoa. Don't spoil it.
Oh, my bad. Don't worry. That's just the tip of the iceberg there. Wow. There's a lot more. I'm going to go into the intricate patterns of how that's organized and how it's all integrated together, and why instead of fragmented pieces of sensory information, it's actually a coherent, unified whole. We got to actually understand why that's the case. Sounds very interesting.
Yes.
So hold your horses.
We are also going to, in the machine learning topic, we are going to be going over something called Bayesian LSTMs, which are
pretty niche,
or depending on how you say it, Bayesian LSTMs, and it is a specific type of LSTMs. And for those that don't know, LSTMs are the things that make things like ChatGPT and whatnot work. So we will be going over that. And for our nootropic topic of the day, we are going to be going over PE 22.28.
That is fun. Excited.
Which doesn't sound like much, but there's a lot there.
A lot to it. A little too much. It's kind of hard for me to comprehend. I'm being honest.
So we're going to delve deep into that in the second hour. But if you tuned in before, as you know, the first hour here is just going to be a little bit of free flow, us catching up, just some regular conversation.
Yeah, regular conversations, but not any normal regular conversations.
Not regular conversations.
No.
Very irregular conversations.
Regular and insightful.
Mm-hmm.
Yes. Who knows what we're going to talk about? It's like a little bit, it's like a gift box. You don't know what you're going to get until you open it. So you better stick around.
Yeah.
Or skip to the second hour.
Oh, also we are, when, do you know when our cameras are coming in?
Sometime between, it's the 15th through 17th.
Okay.
So it's narrowed down a bit.
Maybe by next week.
Maybe by next week. It might even be sooner. Sometimes it just gives a random like day, and then it comes like a week earlier, and you're like, oh, okay, that's great.
And then sometimes it never comes at all.
Yeah, and then you sue Amazon for that.
So yeah, we should have those come in. We have got 3 cameras that we're getting in. So hopefully spruce things up a little bit. And then on top of that, I'm working on developing our own WebRTC client that will allow us to send signals, from our computer with our webcams attached to my computer.
Yeah.
The reason for that being that we don't have many friends and we don't have any director friends. And so we have nobody here to actually control camera scenes and whatnot. And so what I'm going to do actually, and this will be kind of almost a fun demonstration for the podcast too, would be what I'm going to do is I'm going to actually create an AI to control our scenes for us and our camera shots and decide which of the camera shots is the best one for the moment. And so, if you think about the choices that a director makes during that, it's, okay, who's talking? What are they talking about? How often and / likely is it for the other person to jump in here or give some sort of response? And how much movement is going on in, both individual scenes.
Mm-hmm.
And all these things are factors in determining the best shot and almost predictively determining the best shot in an ideal setting. And so the goal is to get this AI to be able to, and I don't want it to be, it's not going to be a large, crazy resource intensive model. I want it to be really small and runnable, Yeah. But the goal is to make this thing able to accept our WebRTC video input features, like certain specific features, and be able to process them and determine what the best scene is going to be for us. And so hopefully we'll be able to demonstrate that working, supposing it actually works out the way that I think it's going to.
Hopefully.
So yeah, hopefully we'll be able to get that up and running.
Sounds incredible. I'm not gonna lie. I really want to learn how to code. Like,
I know.
I'm so sad that my life is so crazy. Like, it's fun. I love it. But at the same time, it's like, now I can't focus on what I kind of want to do. Like, well, because you have to really put in a lot of time. And what you do,
it is very, very, especially at the beginning, it's very consuming as far as mental processing goes, because it really, unless you're just one of those people that naturally has always thought that way, it takes bending your mind a little bit out of its normal comfort zone in order to kind of get so it's so worth it, but like it does take a lot to kind of get yourself comfortable and going.
No, yeah, that's definitely true. And if I have a teacher like you, I know I can do it. So
I don't know, I'm not good of a teacher, but we'll find out.
I'm eager to learn. So whatever you teach me, I'll take it in as best as possible. I'll make it work. It'll happen. And plus, we kind of did do a little bit. That's kind of how we first kind of started, like, really getting to know each other.
Yeah.
He was teaching me Python, and that ended up kind of just developing into us talking for hours and hours.
We could never actually get to the Python because we were talking about other stuff.
After 3 hours, we'd be like, "Do you want to start?" I'm like,
sure. We should probably start now.
Start doing that. So I don't know how effective it was, but it gave me a pretty good, baseline understanding of Python, at least. I don't know if I remember it that well, but I'm sure like everything you said, I'll be like, take it right back up pretty easily.
Yeah.
So that's good.
Well,
dude.
Yeah. we didn't get very far, but
no.
yeah.
You know, it's very interesting because I'm so used to having just like super naturally long conversations with you that I have to like stop myself when we're like preparing for the podcast because I'm like, Frick, I don't want to talk for like 30 minutes about really good stuff.
There's part of me every time I bring up a new topic, there's like, should I save this for the podcast?
Yes, that's exactly what I do. And so, you know, which is fine, I guess. Guess we have to wait until everyone's watching us in order to talk about the good stuff, you know? So
there's part of me, one of the things that's really interesting about programming for me, there are certain elements of programming that can be frustrating and difficult, like debugging code is never fun for anybody.
Yeah.
And there are certain things that I really just make me almost like in a weird way kind of giddy while I'm doing. And I figured out one of those things the other day while I was I have a natural bent to want to like make restructure everyone else's code and way of doing things into a more organized system, a more cohesive, organized system. That's why I built the audio library that I released on GitHub called Waveformer. And it's an audio library that basically is meant to be a single universal audio library for Python, and it makes things super high level and simple, and allows you to do conversions between different forms of audio. Like you can convert things to tensors, which are used for machine learning. You can convert things to bytes, and you can load things easily in different forms, and you can perform audio analysis and audio transformations without changing the original waveform. And so there was so much like, I just got tired of using a bunch of different tools for different audio analysis tasks and having to use like several lines of code to switch between these different forms that the audio takes. And so I built an entire library of audio tools that all kind of fit cohesively into a single interface. And that's my natural bent to do with everything that I do. It's like make everything cohesive and easy to use and fit within the same system, you know?
Yeah.
And so the other day I was doing that. I was like, I started doing it. I was like creating another library. I was like, I gotta stop myself here.
No. Can't get into this. How long did that audio library take?
Over a year.
Dang. So if you're gonna start another one, that would probably take a pretty long time.
Yeah. I mean, a lot of it was off and on that I was working on it. And a lot of the time was spent, a good portion of the time was spent trying to figure out how to wrap C code into Python, because I wanted to use I wanted to build this super extensive C library, which is, C is a different coding language than Python is. And I wanted to bring this super extensive C library into Python and be able to use it within Python because it had already a ton of really good stuff in there.
Yeah.
And C code is faster than Python code. And so it adds that added benefit of being super fast. And so I spent a good amount of time not only figuring out how to properly do that, but also figuring out how to functionally and efficiently wrap this massive library. Because I'm not kidding you. Like, this thing had several hundred files worth of code.
Oh, wow.
In there. And so I basically developed an entire program that would read the C code in the file and then translate it into Python code for me.
And I I feel like that is in of itself a product. That is in of itself a product.
Yeah, it wasn't flawless, but it did what I needed to do, and I could correct its I could correct it, go through and correct its errors. So if I had spent more time in making it flawless, yeah, it could have been, a pretty useful product for people.
Oh yeah, definitely. Yeah. I mean, so what exactly is C code?
Well, C code is just a different, it's a different programming language. It's a different way of communicating with computers than Python code is. C code is a lot harder to understand intuitively, and it's a lot more comprehensive in certain ways than Python is, because it gives you direct access to things like object memory. Like you have to oftentimes have much more direct access to the places in the computer where the objects are stored and the memory addresses and whatnot than you do in Python. Yeah. Python kind of handles a lot of that stuff for you. In C code, there are tasks like, for instance, deleting objects when you're done with them. In Python, if something isn't referenced again in your code, it's automatically deleted by the garbage collector. And so it handles that stuff for you on an automatic level. In C, it doesn't do that. And so to my knowledge, I'm not an expert in C, but I'm pretty sure about that. Based off of my intermediate knowledge of C, it doesn't do that. And you have to actually manually delete the things that you want to delete, like specify when you want them to be deleted and whatnot. And
I see. Yeah, makes sense.
It also, as a result of that, of being kind of a lower level interface, it leaves a lot more room for potential severe problems. So there's a lot more, you have a lot more control, but there can also be a lot more problems. And as a result of that, control that you have. And so for instance, if you forget to build in deletion for a loop that you're running on something where it's creating new objects, then you could very easily fill up the computer's memory without intending to over time.
Okay. So you have to be very careful and intricate while you're working with it. But the benefits are you have direct access to the object's memory.
Well, the benefits are that you just have a lower level interface with which to communicate with the computer. And so you are able to more directly control hardware. And like, for instance, if you need to communicate with a GPU, it's very difficult to do that in Python in any sort of low level way. Like you can, on a basic level, you can do things for machine learning, like offloading tensors and whatnot onto the GPU. But if you want to actually control the hardware and the memory itself and whatnot in the GPU, like that kind of level of control is not something that is easily achievable in Python at all. It's something that is natively achievable in C.
Interesting. Yeah. And so what's really cool is that your converter can take that easy way of doing it and convert it into the harder way on Python.
Right. Well, what it does is it takes the code that was already built in there and it loads it into the computer's memory and then sets up references between Python and the C code. So if there's a class in of things in C or a function in C, it will take the organization structure that's in C. It will write out a Python equivalent of that then references the C code in it.
Okay.
And so it's using Python to run the C code basically through a similar structure in a way that kind of makes sense for Python developers.
So I guess even still, you would have to fairly understand C code in order to use it.
No. Python developers don't have to. That's the whole purpose of that integration, is that it takes care of the communicating with the C code and the loading of the C code for you, and the determining what the structure is and like what the variables are that can be sent to the C code. It determines all of that. So like, if a function in C is supposed to take an integer as a parameter, like let's say we're loading an audio, and it needs to know an audio file, and it needs to know the address, the location of the audio file, and maybe the sampling rate, although that would already be contained in the file, but we'll just use that as an example. The sampling rate of it, then it would need according to what was laid out in the C function, we would determine here are the parameter names, and this is what the type of parameter they are. They need in Python, what is known as a string and an int, an integer, and that's the proper format for Python to send things over to the C code. The C code, there's more data types than and different data types than Python has, so it's not always a direct translation, but that's the purpose of the program, is to like go in there and determine what this function is called, what parameters it can take, and then bring it back into Python and write out code that lets developers know, okay, so I just pass an integer and a string to this function, and then it handles the sending that.
Oh, okay. Oh, that's genius. Yeah. I love it. Oh, that's great. And you literally just did this to make the process of making the library easier.
Yeah, well, because the thought of translating 200 pages of C code into Python classes was just, I was like, there's no way I'm ever going to finish that.
And it's such tedious work.
It is tedious because I'm not coming up with anything new. It's repetitive stuff that has to be done. So if I can translate my knowledge of how to do that into a program and code the logic for that I would use if I was doing it, then the program can just do that for me, and it can do it way faster than I can.
Yeah, no, definitely.
Yeah.
So we're getting a new president. Anyway, we're getting a new president soon. How do you feel about that?
We are? No, just kidding.
Yeah. I think her name's Kamala or something. Yeah. She's a great
Nicki Minaj.
Yeah. Oh, that's right. Kamala is still the vice president of Nicki Minaj. I see. Was it her that was at one of the Democrat rallies that was like singing and dancing? Everyone was like, yeah. I know she had like a bunch of rappers, which I thought was really funny. I was like, that's cool, I guess. Like, I'd go if it was like a concert.
You know what was weird? This is a breaking topic. I was watching the Gladiator 2 trailer.
Oh, dude, that was yesterday. Such a good movie.
I haven't seen it yet.
So good.
But I was watching the trailer the other day. And they had a rap song behind the trailer.
Oh, interesting.
Yeah, it was like a rap. I think it was Snoop Dogg or something like that. I'm not up to date on rappers, but and what was weird was there was like one word that kind of was Roman. It was like he mentions Colosseum in the rap song, but that was
just about it.
Yeah.
Oh, that's funny. Yeah. I don't know.
I was like, where's Hans Zimmerman? You know who that is, right?
Hold on.
Oh my God.
Wait, which character was he? Sorry.
All right. Hans Zimmerman is one of the greatest composers of all time.
Oh,
yeah.
Okay. Yes,
he did the soundtrack for the original Gladiator.
That makes sense.
Yeah.
And listen, there weren't any rap songs in the actual Gladiator 2 movie, so I kind of wish there were. It kind of would have made it kind of cool, you know.
I didn't really have a whole
slash someone's head off.
A huge problem if it was a separate movie, but the fact that my expectation going into the Gladiator 2 trailer was for it to have a similar vibe to Gladiator, the original Gladiator, which had Hans Zimmerman as the composer, kind of just threw me a little bit.
Oh yeah, and plus, I mean, if we're getting critical here, the quality of the second one was not anywhere close to the first. But I still really enjoyed the movie. It was a great movie, great story.
Looked like the cinematography was good.
Yeah, it was good. Very creative. I thought it was very well done. Like especially what they did with like.
I haven't seen it yet, so don't spoil anything.
Yeah. Well, I'm not gonna spoil it, but what they did at the Coliseum was really cool. Like all the different ways they would fight and stuff, and how the emperors would set it up. It was really fun. So go watch the movie. This is not a promo, I promise. Wish it was, but
yeah, we're not getting paid for this.
No, so maybe don't watch it because we don't care. So, exactly.
Yeah, it still looked good. It doesn't it have the Mandalorian in it?
Yes.
The actor that plays Mandalorian, also in Last of Us, he plays the main character in The Last of Us.
Dude, his name is he's so famous. I've heard his name at least 20 times since I've seen the movie, and I still can't remember his name.
I know. I can never remember either.
I haven't been taking my Primaracetam. I think that's what it is.
I ran out of mine.
Oh no. Yeah, I definitely need to get some. I'm almost out. I've got like half of it left on my last bottle.
Besides re-recording our previous overview of NSI 189, which we kind of got part of it cut out during our podcast, which we need to do. Maybe we can do it real fast after this podcast. We should also record some. We should also record some segments on some of this stuff, like some of the experiential segments, like your experience with Primaracetam, my experience with Primaracetam. I could talk about every single one of the Racetams, and I could talk about why am I blanking on his name? M.E. something. I'm blanking on his name. But some of the others, I could talk about experientially, and it might be kind of cool to do an experience segment part of it where they're separate, smaller videos where we talk about what our experience was with those.
Yeah, I think that actually sounds really fun.
Yeah,
I'm down to do that.
Oh, did you hear? Speaking of movies, since we're on that topic, did you ever read the Eragon books?
Yes.
You did?
Yes.
No way, dude. Those were my favorite books.
So good.
Favorite books growing up. I read them so many times. And I remember when the last one, my little sister was actually recalling this recently, when the last one came out, and I got it in the mail. I was so excited as a kid. I ran screaming down the street. I was like, yeah. But I found out recently that Christopher Paolini is working with Disney to turn those into TV series.
Wait, I think I heard something about that. And I was like, there's no way. That would be like incredible. I don't even care.
After all these years, hopefully we finally get a decent Eragon translation.
Please, I will fund that myself if I can. I'll go into debt.
I was so disappointed with the movie because of the fact that, like, in my head, this was like a movie playing out. Like,
I heard it was bad and I didn't watch the movie.
It was in my, like, when I was reading it in my head, like I was seeing everything as like a movie in movie terms, like Lord of the Rings style, and I watched the movie of this massive book. It was like less than 2 hours. I think the movie was, it was less than 2 hours long. And, I just was so disappointed in almost every single element of it, because it felt like a B- grade movie.
Yeah.
Like, it felt like something you would see on television that you'd never heard of before. And you were just watching because there was nothing else on. And it could have been so epic. Like, it could have been a Lord of the Rings, Game of Thrones level of cinematography, because he spends so much time talking about the scenery and the world and building up the visuals, and talking about I know it's real. I verified it. So and talking about the cultures and whatnot that are built into it. And he like spends so much time on all these details. And not only did they not capture those details in the movie, they changed a lot of them and just completely skipped over a lot of stuff and spent no time developing. And if they were going to make that into a movie format, they would have had to make it a similar length to Lord of the Rings.
Mm-hmm. Yeah.
If they were going to try and fit all that in there.
It would have been so worth it.
It would have been
incredible.
It would have been. But I'm glad that they're doing it in a TV format now, because I think it's much more suited to how long those books are.
As long as they do the Dwarven City part correctly, I will be so happy.
What is the name of that city? It's been so long since I've read the book. D something?
I know. I'm like trying to remember the characters' names and everything, but I'm like,
we have Arya, that is the elf.
Yes.
We have Brahm, which is the old dude.
This brings back so many memories.
Murtagh, which is the Eragon's friend. We have Salone, which is the butcher in the town that's really obnoxious.
Oh yeah.
We have, wow, I can't believe I'm remembering these names.
Dude, as you're saying these names, all of the memories of the books are coming right back to my brain.
We have Galbatorix. We have the magician dude, or the sorcerer dude, whose name starts with a V, I think.
Yeah. I think I'm gonna read the books again.
I know, me too. I want to read the books again too.
Awesome. I know it's gonna take over my life. I can't do it.
And then we have Saphira. We have what's the red dragon's name? Blanking.
Yeah, I won't remember. It was way too long ago.
Oh, and then you have those really creepy dudes with the hoods. You remember?
Yes.
Like those guys with like the beaks.
Yes. Oh my gosh.
Oh my gosh, like, dude.
They're victims to the bone.
Yes.
Mm-hmm. And don't they show up in like the first village because he raises the dragon?
The Eragon equivalent of like the Nazgul almost. Like these just really, really creepy like.
Dude, I want this to be like so good. It has to be.
I need to.
My expectations are way too high. I need to lower them.
I need to be creeped out by the way that these guys are represented. Like they were so freaky to me in the books.
Mm-hmm.
The way that
it's got to be at least
TV
14, bro. Like seriously, if it's not, if it's like kid friendly, I'm gonna be like,
oh no, it needs to be like,
no, it can't be.
I prefer to at least be, like. It at the very least needs to be what, PG-13, like Lord of the Rings was PG-13. Yeah. At the very least needs to be PG-13. I would be okay with it being R.
Because after they flee the first village and then they go to that one city that was like overrun by the orcs, there was like a huge giant pile of like bodies.
Yeah, no, there are some very gruesome stuff in there.
It's very gruesome if you think about it. And it's supposed to be like this big, like kind of like moment almost, kind of like a shift in mindset. And like, that's really important,
Yeah.
Like, it needs to be for adults, being honest. I think that's what they should cater towards, because in the long run, it'll do them so good.
Yeah. Like, I think Lord of the Rings was a really good compromise between kids and adult, kind of. The way that they did that, because they still showed some grosser, scarier stuff, but they didn't go overboard with it, but for the Eragon series, like I could see it being a PG-13. Like I could see them doing a PG-13 and doing it right. I think they're more likely to get it right if they embrace the R.
I think so too. Fully embrace it. TVMA, just fully. Dude. My life's complete now. I have a reason to live at this point. This is wonderful. This is it. I had other reasons, but just like, here are my reasons to live. This is now the reason to live. It's way up here. It's this Eragon TV series. That's all I'm gonna say.
I agree.
Nothing compares. Oh,
I'm so stoked.
I'm so excited, man.
Those are like people would get like the level of excited people would get over the Harry Potter series when the Harry Potter series or the Harry Potter movies came out when I was younger is the level of excited I got over the books and would get over the TV shows being released.
Yeah, definitely. I mean, I'm sure there are so many fans that once they really hear about it after like done the big promotions, they're gonna flip out. There's already people flipping out, you know? Like there are still people that I've seen online that'll put like, you know, like different like art still of, you know, the books.
So describe in your head, like describe Murtaugh as a character. Like how did you visualize him in your head? You can draw an analogy to another character if you want.
So I'm really bad with names. Which one was Murtaugh?
Murtaugh was Eragon's friend that ended up with he had the sword, the red sword.
Oh, yes, that guy. Honestly, I kind of viewed him as like a little tan, very, and for some reason in my head, like not a lot of my characters that I put in my head are like really attractive, but I put him as really like good looking guy with like
moody,
and like straighter brown hair, and like sharp eyes and like tan skin. That's kind of how I put him as.
Yeah, I always pictured him as a really good example of probably a slimmer version of the Winter Soldier in Captain America.
Yeah,
you know, the guy with the long hair, like long straight brown hair that parts like that, and is like got very, very distinctive look, sharp eyes, like that kind of thing. Like a slimmer version of him is kind of how I pictured Murtaugh, and kind of having that moody teenager like angst about him not being a teenager, but well, maybe he was. I don't remember what his age was, but
I'm glad you asked that character because I'm trying to think about what I thought of the other characters and I can't really remember. It's all a blur. I do remember Murtaugh, exactly how he looked. Because I really liked how he looked. I was like, honestly, if there's one character I was gonna be, I kind of wanted to be that dude.
I know, honestly. Me too. I think, I mean, I liked Eragon, obviously, he's the main character, but like, I think the main reason I liked Eragon was that he was with Arya. Like,
seriously.
But the way that he kind of went about that was a little pathetic.
Yeah, I was kind of embarrassed for him, not gonna lie.
Murtaugh was definitely, I related to Murtaugh a lot more.
What was it when they like shared that like, or no, he like had to do like a painting with his magic or something.
Yes,
and it was like a really
very vaguely. It wasn't of Arya,
like a really
detailed version of
but it was like wrong.
And then she got like upset at it. Like, didn't she like see it and kind of like storm off?
Yeah, because it wasn't her at all, and he realized he needed to change his entire view of her. You know,
which was like almost like a dramatized version of her.
Yeah, it was like a selfish version of her. You know, like how he idealized her instead of the real her.
That's super interesting because we do that with people.
Oh yeah, 100%. We do all the time. I mean, if you think about it, like because what drives us, what fuels us, are honestly, in essence, our delusions. You know, like I like to say very often that truth is the only delusion you should have, because it honestly kind of is one to me. But that makes it even more exciting, because just because it's a delusion doesn't mean it's not real. It doesn't mean you can't find it and create it. You know, but something like that actually, you know, when you're not met with that, obviously there can be very negative effects, but then you end up probably getting to the place to where it is good because you recorrect your predictions, and then
Well, I think it's our cognitive projection element of our brain that starts interfering with the actual data on the person, which, our cognitive projection obviously provides some very important things to us because it gives us the ability to project a future that we want to achieve and then strive for that, but that can come with very damaging elements if you let it control your perception when it's not going to be something that's helpful. And so an example of that might be when people, we have almost a 50% divorce rate right now, and I see that happen all the time with people that they get interested in, or even people that get married. They have a idealized projected view of not only the person they're with, but relationships themselves and marriage itself, and what they want out of it. But that is, on a lot of levels, not realistically attainable. And for example, media has a tendency to portray the best parts of a marriage relationships, and has a tendency to idealize certain things and romanticize them. And on top of that, people want someone who is perfect for them and that completely understands them and accepts them, and so with that desire comes a projection of those features, or reading into actions those features, and so that kind of all combines to create this make-believe scenario for yourself, where you make yourself believe that this is setting you up for a perfect idealized future, and that that this person is the thing that is going to make you whole and complete you and whatnot. And that's never going to be the case.
You complete you.
Right.
Even if it's the generative model of another person, it still fundamentally is you.
Right. And it's not a matter of completing you, it's a matter of enhancing you. Yep. Like if you're looking for somebody,
Amen to that.
Look for somebody that enhances you and your life in a way that is complementary to who you are, not somebody that fixes what you see as problems. Because I mean, beyond just that being a faulty way of looking at it, like a lot of people see things as problems in themselves that aren't actually problems, and don't see problems that are problems. And so
strange.
They're trying to think if I can come up with an example of that. Like for me, I used to think the fact that I didn't integrate socially and I had a limited capacity for social interaction, I used to think there was like something kind of wrong with me because of that. And then I find out later, that is just a part of who I am on a personality level, and is something that I don't need to change once I accept like it's fine. I just navigate life like that, like,
and now
with that understanding.
It's hard to socialize with people because there's something wrong with them, you realize.
Exactly.
So it's different. It's flipped.
And with that understanding came the understanding of space and time to be me and by myself with my own thoughts. Like, that's something that's very important to me. And had I gotten married before making that realization there, that could have ended very badly for me. Because I could very easily have gone with the first thing that felt right, for a bit, because it's easy for things to feel right over the short term, period. And before you live together and experience who the other person is on an essence kind of level, and those things don't really come out like that. And if I were to have ended up marrying somebody where space wasn't something that was important to them, and they didn't understand that about me, and I didn't understand that about them, and they wanted to always be with me and whatnot, that could have been a source of severe contention that could have ended up breaking the relationship. You
don't want to go through a divorce. And plus it sounds bad, like, yeah, I'm divorced. It's like, what are you, 45? Seriously. Yeah. I mean, there definitely is some people that I'm definitely kind of worried about. It's like, you don't even really know this person, and you're getting married to them. What are you doing?
Well, you don't even really know you. So
yeah, neither of y'all know either of y'all. Which to me is rather scary. But I mean, I guess there are some people who can do it.
Yeah.
And who have value.
Well, I mean, it does work out sometimes. Like, you end up with somebody that is
actually get to know, and it works great. Yeah, very compatible.
Yeah. And there are times when it works out, like, and you make it work. Like, you both are in a situation where you're capable of handling the differences that arise. But those instances are just as frequent as things not working out. And it's kind of a gamble, a coin flip. Literally, we see our divorce rate as a coin flip. It's a 50-50 chance. And so rather than flipping a coin, they're like, if people spend a little bit more time getting in touch with themselves and getting to know themselves and figuring out, who they are, what's important to them, I feel like they would have a much clearer idea of what they need in life to be happy.
Oh,
and
100%.
For me, it kind of, I've boiled it down to, like, to just a couple really important, things to me. And if I ever end up getting married, it's going to be to somebody that I see as, like, literally like a partner in crime kind of thing. Like, somebody that I just enjoy hanging around and talking to, and that sees a lot of things through a similar lens. And is somebody that I can just have a blast with, and that if those things happen, then I don't see a problem with our future, because, I'm always going to want to keep them, around in any issues that do arise. There's going to be enough of a mutual, like, enjoyment of each other going on that we find enough value to be able to resolve those issues.
It's really interesting because we're such complex creatures. Let's say there's a hierarchy of things that you need to figure out for yourself. At the very top, tippy top, is loneliness, right there. Even though it's at the very top, and there are all these other structures, these things that you really need to figure out, the very tippy top is loneliness. And this is the only one of those problems that is conscious. Nothing else exists in your consciousness. Because listen, if your sexual needs aren't being, satiated or met, then that is obviously, thanks to your hypothalamus, going to send that signal, and it's going to, create some, some problems. And then you're going to have to, and then your body's going to tell you, hey,
things getting sexy here.
You start getting sexy soon, or else we're going to have a problem. We're not going to be able to reproduce. We're not going to, give off our genetic lineage. You need to fix this. And if they don't, well, then, that's obviously going to lead to some sort of anxiety and depression, because something fundamentally is missing, because the only thing that exists is on the same level as hunger. When you're hungry, of course, you're conscious of that. And if you're lonely, you are also going to be very conscious of that. So it feels like almost the only thing they can fix. And even if they do it correctly, at least to some extent, they're mediating the problems, or they're kind of trying, at least to the best of their abilities naturally, to maintain equilibrium within their mind, so that they don't go into panic mode. Because, if the whole hierarchy is broken, well, then you're going to have a really big problem. But at least if we can just kind of like get rid of the tip of the iceberg, so everyone else can only see, oh yeah, it's just water here.
Yeah.
And it'll be fine.
I see genetic like propagation and loneliness kind of as two separate things.
I agree.
And in a lot of ways, I feel like loneliness is a choice. And it's just it's a matter of our values in our head of not finding value in our own company and not feeling comfortable with our own thoughts and whatnot, and valuing sometimes too much the distraction that other people provide, and the need for some sort of positive influence to maintain a positive mental state, and so I think in a lot of ways, like, loneliness is a choice, and by the same token, on the flip side, it's kind of something that is also inbuilt into personalities. So it's difficult to change despite it being a choice,
Yeah.
Like for me, my personality has a natural bent that allows me to handle loneliness a lot better than most people can. And being by myself, like, I don't need other people to be happy the majority of the time. And so it's kind of like almost like a another yin and yang situation. And you, with the flip side of being able to handle like loneliness a lot more and not needing other people, also comes with the less social abilities or desire, oftentimes to integrate yourself socially, because like, I don't care about these people.
I know, seriously. This can end up being a problem down the road, especially if you want to integrate into a functional society. But I think that loneliness you're talking about is a very large chunk of the totality of that hierarchy. And I don't think people just have gotten to at least either the lowest point in their life to really start to activate those networks that then reevaluate how you should orient yourself. I really don't think that they've gotten to that point, or really don't have the awareness necessary for that. And I think that if they don't, then those primary mechanisms will kick over and then mediate their emotional and intellectual responses.
Yeah,
probably. So I'm thinking. But, it's a very complicated process, but that's, at least my analysis of it, and it's, I guess I'm really speaking from personal experience and then doing research on that kind of personal experience, because there's something that's really interesting that I actually talk about a lot, just to a lot of people, is the insula DMN ACC axis interaction. Big name, but pretty much there are many different ways it can activate. One of them is transient hyperfrontality. where there's like a large inhibition of your prefrontal cortex and more primary structures are more interconnected with each other. But there's also something very interesting when you're at the lowest point of your life. This system can actually activate very well. And what happens is that you start to orient and reevaluate everything you can do in life. And that's kind of what I did. Is I had a choice. I was like, okay, you can either switch some stuff around, figure out what you can do with what you have, or you can get rid of it all. What choice are you going to make? And I saw my options in my head, and I was like, let's get rid of it all. Nothing else. And that was actually when something popped in my head. The one thing that popped in my head was truth. Truth. And building up simple axioms that are at the boundary of intellectual thought, where you can't make any further inference. This is the most solid foundation you could have. And don't integrate anything else into yourself, besides obviously your personality, because that's in there at 4. You can't really change that. I mean, you can over time, but it's just, there's behaviors and parts of you that you can't change, but there are values you can change. And I did that. Got rid of them all. Started at simple axioms that then built a foundation for then me to kind of I just got rid of the iceberg. And then I just formed a new one. And then I'm hoping that the very, very top, maybe that longing for a significant other will be at the very end of that. And then I'll be able to find the one building that fully functional hierarchy of values.
That concept of I think everyone should break themselves down at some point in their life and almost be willing to get rid of everything you ever thought and valued, in the sense that you're willing to disseminate and figure out what actually is valuable to you and what is not, and what is truth and what's not. Because for me, there were a lot of things that were not valuable to my existence and were actually a hindrance to my existence. And once I got to a point where I realized the need for a different way of doing things and looking at the world, and that a lot of my held values just weren't working for me, I got to that point of seeing the need to break myself down and start anew, kind of like you were talking about. And so I started with a simple axiom, to use your word. Hey guys, welcome back.
Hello.
Looks like we got our issues sorted out with the video. Sorry about that. Eventually we want to be connected directly via Ethernet, so we don't have any connection dropouts, but right now it's not currently possible to do that. So well, hopefully that'll be the last one for today, and we'll
keep checking to make sure, guys.
We will try and keep checking. Exactly. So as you guys may or may not know, if you watched the last one, this is the second segment, so we're going to go over a couple things on the to-do list or the agenda. The first one is our nootropic research of the week, and for today we are going to go over PE 22.28 and discuss what it is and kind of some of its mechanisms of action, its observed effects, some of the research that has been done on it, and then kind of discuss the implications for different cognitive either deficits or cognitive developments But yeah. So, Jacob, I don't know if you want to go over. Do you want to go over the overview, and then I'll handle the cognitive effects?
Yeah, for sure. So I'm going to be looking at my notes because a lot of these words are not very familiar to me. Okay.
This is a very complex. Okay, first off, I do want to say, first off, not only is this particular nootropic one of the more complex ones,
yes,
but molecularly, it is one of the more complex molecules as well. If you see it in its molecular form, it is actually a very big molecule, and it has a ton of different groupings within it, and it's probably why it's obviously why it's a peptide and not a small molecule, because peptides are larger than small molecules. But it being a peptide, there's a lot more molecularly that's going on. And so, with that, we'll go ahead and kick it off for us.
So PE 22.28, it's a 7 amino acid peptide and is derived from the blood degradation product of spadin, I'm guessing. Yeah. And it emerges from the post-translational maturation of sortilin in the Golgi apparatus. And this peptide has shown promising potential in the treatment of depression and stroke-induced cognitive deficits. And so now I guess that's kind of a little bit of overview. So we're going to go into the cognitive effects, and the mechanisms of action, then the receptor interactions, and the brain regions.
Yeah,
so it'll be pretty fun.
Yeah, the main area of research for PE 22.28, or for now we're just going to call it PE, because I don't want to go through that name every time. But the main area of research for PE is as a antidepressant, and much like some of our previous nootropics, antidepressant nootropics that we have covered, it actually addresses this through neurogenesis. But the studies that have been done on it have shown a marked improvement in many behavioral tests that are designed for depression, such as the forced swimming test and the novelty suppressed feeding test as well. And they noticed during those tests, they noticed a significantly reduced immobility time, as well as a reduced latency in the time it takes for them to eat as well. So those were the main tests that showed promise for its antidepressant properties. Now, in addition to its antidepressant properties, PE also demonstrated some pretty promising cognitive effects, primarily through its influence on neurogenesis and synaptogenesis as well. And for those that don't know, neurogenesis is the creation of new neurons within the brain, and synaptogenesis is the creation of new synapses in the brain. So potential connections between neurons.
Is that for new existing neurons or pre-existing neurons?
I would imagine eventually for both, but for new existing neurons would already have unfilled synapses.
Would be
so
better integrated.
I think the more prominent effect would be on the pre-existing neurons.
And that's actually really important. Side note real quick, but there are a lot of new neurons that actually get generated in the brain that don't actually integrate into a neural network, because there's a very precise time frame for them to do that. And if they don't match those qualities, then it actually stops. So something like this that actually enhances the ability for those neurons to form new connections is actually vital in and of itself to neurogenesis.
Well, yeah, and if you were to combine that with something like LSTM, which has the ability to increase the learning rate of and the ability to adapt, your neurons' abilities to adapt and relearn data or change the way in which they function. If you were to combine those two together, you might end up with a situation where your old neurons not only are building new synapses, so thus having new capabilities, but but you put your brain in a state of increased plasticity, so that it tries out a bunch of new firings so that those synapses can form together.
Nice. And
anyway, so
all of that.
What's that?
PE does all of that.
Yeah. Well, what's really interesting is that normally neurogenesis takes a bit to prompt and to stimulate. It's not something that happens very quickly. There are several other substances that I've looked at in the past that have created neurogenesis, but oftentimes it's about a week that it takes for them to start taking effect. What's interesting about PE 22.28 is that this neurogenesis effect was noticeable after only 4 days.
Wow. And maybe this is why it kind of has an antidepressant effect, because of the quickness of its usability and effects.
Yeah. And what's interesting is that the studies have shown that with this particular molecule, the modification of the ends of this molecule and the modification of the groupings on the end of this molecule can actually change its behavior. So it can be tailored. There's a version, let me see if I can find it here. There's a version here. It's a GAPE 22.28 analog where the glycine at position 22 is replaced by alanine, and that one was shown to have a significantly increased neurogenesis property to it. So things like that demonstrate creating analogs of this that have the different elements changed and tailored, shows that like this molecule is something that is versatile and can be tailored to specific usages and whatnot, which is kind of cool.
Wow.
And studies on mouse cortical neurons have shown that that PE 22.28 and its derivatives increase the expression level of PSD95, a protein that plays a critical role in synapse formation and function. Also, another thing to note here is that in rodent models of ischemia, the PE has been shown to reduce stroke-induced cognitive deficits. So post-stroke, the cognitive deficits that cause loss of motor control, things like that, PE 22.28 has been shown to significantly reduce those effects.
Wow.
So post-stroke, allowing for post-stroke recovery, faster post-stroke recovery. Yeah,
that makes sense.
So yeah, it's got a lot of potential applications, and given that it has neurogenesis and synaptogenesis properties, I imagine that its implications could even extend to things like Alzheimer's and potentially Parkinson's disease as well. And as a potential treatment, even though it hasn't yet been, to my knowledge, investigated for those areas, there's a lot of overlap in the way that it functions with the way that a lot of current research is being geared towards in developing a treatment for Parkinson's and Alzheimer's.
I definitely think, even if it's maybe not something that's too noticeable in people with Alzheimer's disease, I think that if everybody who had a very high likelihood of getting Alzheimer's disease later in life,
using it as a preventative,
yes, very good preventative, in my opinion, because with Alzheimer's disease, right? It's fundamentally it's a lack of insulin in the brain, and so if that's the case, if there's a lack of that there, but there are still connections that have deep-rooted themselves, you might actually be able to combat that in a way that you weren't able to before and see better improved results with the current medicine or practices they use to, combat Alzheimer's disease. So I think it could definitely work as a preventative very well. But yeah. So
you go ahead and cover the mechanisms. I do want to jump in on one of the things here.
Jumping in all of it. So PE, it's a highly selective inhibitor of the TREK or TREK1 channel. And it's a 2-pore domain potassium channel, and it exhibits a higher specificity and affinity for the TREK1 channel compared to spadin, which is its parent peptide. And the IC50 of PE for TREK1 is 0.1 or 0.12. Is that nanometers? Wait, what is in? I'm tripping.
Yeah.
It is?
Yes.
Oh, okay. So I was right. Great. I was like, is that nanometers? Yeah, so it is. So it's the IC50 of PE for TREK1 is 0.12 millimeters, and specifically lower than the 40-60 nanometers.
Basically, it just means that it's a much smaller molecule.
Yes, very small. And this enhanced specificity and affinity may contribute to the improved efficacy and reduce side effects of PE 2228 because there isn't a large amount of residue or leakage.
And for those that don't know, the TREK1 channel is referring to a receptor site. It's a specific type of receptor site, and I mean this particular one has, to my knowledge, has impacts on a lot of different things. One of which is your learning, right? Or your ability to learn new information
and combats depression pretty well.
Yeah,
as well.
So being a 2-pore potassium channel, the pores here are referencing the whole transmembrane domain and P-loop structure within the neuron at the receptor site itself, where the molecule interacts with and attaches to, and how big the channel itself is there. And so it's basically describing the structure of the channel when it says that. And there are a whole lot of different ways that I could go into that, or several different ways that I could go into that molecules can interact with receptors in order to change the properties of that receptor site to make it easier or more difficult for certain molecules to interact with it. Basically make it more likely to repel or to attract certain molecule types. And so I don't know if I should get into that now or not, but like maybe for a future video we can go into that.
That sounds fun.
But is everything from actually physically blocking the pore itself to changing the charge on it so that it changes its interaction with its surrounding molecules, to changing the width of the P loops, and the helical structure that makes up the receptor. And so it can have both impacts on the entrance itself, as well as the overarching structure of the receptor, as well as the surface domain properties on top of it that attract or repel molecules. And so there's a lot going on there. And that knowledge is of how those potential interactions can happen, can oftentimes better understand how stuff like this could interact with those receptors. In fact, a fundamental understanding of that allows us to be able to make predictive or create predictions on a molecule's interaction with receptors.
Yeah.
So that we can do things like create a lot of different variations of molecules and see what the interactions might be with that structure, with a structure contained within that receptor. Like for instance, the TREC1 receptor has very, pretty specific properties and structures to it. And so if we take a molecule of like this one, for example, we can now create a prediction on how that is likely to interact with the TREC1 receptor. And
fascinating.
There are programs and models, machine learning models and whatnot that have been developed out there for helping with those kind of predictions. I actually have one on my computer right now.
Cool.
That it's a software that is designed to help you visualize in 3D a molecule, and also potential receptors and whatnot. And it's really, really fascinating stuff. And so
it's really cool.
Definitely delve more into that if you're interested, and we'll probably try and cover that in a future video.
But back to the TREC1 channel, inhibiting it can lead to the depolarization of neurons, and this makes them more likely to fire action potentials. And this increased neuronal activity can have various effects, including the release of neurotransmitters and the modulation of signaling pathways involved in mood regulation and cognitive function. And what I find really interesting about a lot of the nootropics that we've been talking about is that it's correlated with the actual dynamics of your life. And so if you're not taking even just baby steps towards goals and living a better life, a more productive one, then I don't know how much effect this is going to have, because it's not frying anything. It's enhancing the current correct pathway. So it's making it more accessible.
Like if you were to take it and then just sit there and do nothing,
you're not going to feel that effect.
Like there would be no effect, because there's no reason for any neurons to fire.
Yeah, there's no reason for them to fire. There's no reason for new neurons to integrate. What connections are you forming?
Probably one of the reasons why the most visceral effect that I felt from primary stem was while I was learning Python, because so many of my synapses were having to fire to try and understand what it was I was learning and to try and integrate this new information, that it was resulting in a lot more of my brain firing than normally would have, which is probably why I felt that tingling effect.
Yeah, definitely.
But I did want to point out here, not just inhibiting, but actually regulating the excitability and permeability of the membrane potential there. So it just doesn't just inhibit, but it can actually regulate
it. I see. Yes, that's pretty cool. And furthermore, modifications of PE's N or C terminal ends can maintain or abolish TREC1 channels activity without affecting its affinity.
So like what I was saying earlier, by creating this, by modifying the ends of it, the end groupings, like you can adjust and tailor its effects.
Yeah. So it suggests that the core structure of PE is essential for its interaction with TREC1, and modification at the terminal ends can fine-tune its activity, modulate it. And another important aspect of PE is mechanism of action is its improved action duration compared to spadin,
which is its parent molecule that it was derived from.
And while spadin has an action duration of 7 hours, PE and its analogs have shown an action duration up to 23 hours,
which has incredible implications for potential treatments in pharmaceutical, because it brings it from being an irregular, consistent, repeated drug that you would have to take multiple times a day, to being something that you simply take one time a day, and it lasts like once a day, gives you an hour break duration there, and then repeat the process. And very, very simple as a kind of a treatment or a pharmaceutical.
Yeah, and a study highlighted that a partial peptide of spadin similar to PE showed higher selectivity to TREC1 compared to the full-length spadin peptide. And this further supports the selectivity of PE 28 for TREC1 and its potential as a therapeutic agent. So pretty incredible.
So the receptor interactions, kind of like we've talked about, is primarily works through its primary mechanism is through the modulation or regulation of the TREC1 potassium channels, and that's kind of one of its main ways in which it treats depression. And there is potential implications, though, for other receptors downstream from that, obviously. Like, for instance, if the TREC1 downstream has a nicotinic acetylcholine receptor, and so it fires as a result of the TREC1 regulation. Maybe that downstream acetylcholine receptor fires as well. So there are implications downstream for things like that, but its direct receptor interactions are with the TREC1. To move on to the brain regions that it affects, the primary region, like many of the nootropics that work through neurogenesis that we have been discussing, its primary region that is going to affect is the hippocampus. It causes neurogenesis and synaptogenesis in the hippocampus, which is crucial, obviously, for learning and memory, which is another reason why I think it could be investigated for treating Alzheimer's and potentially Parkinson's too, but depending on the actual areas in which it interacts with. But Do you want to cover the
effects on brain networks?
The potential effects on other receptors? I kind of already briefly went over that when I was yammering earlier, but
so considering its derivation from spadin and its effects on neural activity, it is very plausible, though research isn't exactly certain, but most likely P22.28 interacts with these receptors. So we have the serotonergic system, right? Spadin has been shown to interact with 5-HT and mGLUR receptors to modulate serotonergic function. And given the structural similarities, PE22 might actually interact with these receptors as well. And, PE22, it has its effect on neurogenesis and synaptogenesis. And this suggests that there's potential interactions with receptors involved in these processes. This is like NMDA receptors and
AMPA receptors as well.
AMPA receptors and nootropic factor receptors as well.
Neurotrophic.
I always say neurotropic because I think of it as like nootropics. And I'm like, shoot, nootropic factor receptors as well. And considering the role of TREC1 channels involvement in stress response, PE might interact with receptors involved with stress regulation, like glucocorticoid receptors and corticotrophin releasing hormone receptors as well. So those are probably the most likely receptors it's involved in.
And again, like downstream, it may have downstream effects. If it affects one receptor, it could have downstream effects with other receptors. But it looks like the ones that have been verified are the TREC1 receptors. That's the only one that's been verified for this specific version for PE22.28. However, its parent peptide has been shown to also interact with 5-HT receptors and other serotonergenic. God, I always trip over that word.
That's real.
And so it's possible that it could also interact with those receptors. And on top of that, like I was saying earlier with the kind of downstream, like nicotine, acetylcholine possible interactions, you've got the NMDA and AMPA receptors, which are common receptors for learning and increased cognitive processing abilities. So
nice, yeah.
A lot of potential here. I mean, like I said earlier, it not only its potential stems beyond just depression, and obviously for us, the interest, is the interest that would be more relevant to us would be the nootropic benefits to it, and possibly more for you. And it's not just, its potential doesn't just stop at depression because it's being researched for depression at the moment. There are many other potential issues that it could be used to treat, such as Alzheimer's and that kind of stuff. So,
yeah, definitely.
Very interesting molecule. And if we cut this segment from the video and post it as its own separate clip, I'll probably put together a thumbnail of the molecule itself, a 3D view of the molecule itself, so you guys can see how complicated it is, because it really is a very large molecule. It's got a lot to it. I was in the software. I was looking at it and was hovering over the different groupings of atoms within the molecule itself. And every time that I thought I had covered every type of grouping that was present, I would come across a new one in there. It just has like so much going on in it. So it could be cool to even sometime in the future do separate videos with more detail into the molecular structure of some of this stuff, and kind of pick it apart, so to speak. Yeah.
Seriously.
Okay. Well, that concludes the nootropic section. That was a bit of a hefty one.
Yes, that's for sure. Quite complicated, but the implications are quite profound.
It is. It is. I am interested to see some large human trials done on this.
Oh, I'll volunteer as long as I get.
I volunteer as
I
tribute.
get it for free.
Yeah.
It's like sick. I can just take it. It's wonderful.
Yeah.
Hopefully they'll give me a little extra take home with.
Well, they probably, unless you got diagnosed with depression, they probably wouldn't.
I'm really
include
sad.
you in a trial. Yeah, unfortunately.
I'm really sad. I need some PE 22.28, please.
0.28.
0.28.
Do you want to go over your
what I did some research on? The thalamo-cortical system?
Yeah.
Yes. So you might be like, okay, thalamo-cortical system. What the heck is that? Listen, super simple unless you get into the details, which we're going to go into a little bit about, but I want to give y'all a nice, good overview of first the thalamus and then its connections and how it interacts with itself, and then further integrates with pretty much the entirety of the cortex. So everyone pinch their nose. Pinch it. You got to do it. So as you're doing this, I want you to think about your current experience, the sounds around you, the feel of your surroundings, the thoughts flowing through your mind, everything you are experiencing right now, because you're pinching your nose. So nothing's going through your piriform cortex, through your olfactory bulb. So all of this is being orchestrated by your thalamus in a precise neural symphony of interaction. Okay, we can let go of our noses now. But that was just for the experience. Okay. So I don't know what he's going to do. I'm going to do it like this, but pretty much, okay, so we have the thalamus. It's derived from the Greek word thalamos, meaning the inner chamber. And it's actually very modest in size. It's about 14.5 centimeters in length, weighing approximately, 5.7 centimeters in length and weighing approximately 14.5 grams. And you can think of this structure as this bilateral structure, because it's on two parts, both sides of the brain, this little walnut size shape. And this will be important for an analogy later. It's a little walnut sized structure that houses the complexity and networks that is essential to what most neuroscientists thinks is essential for our generation of conscious awareness. So there was some research done by Murray Sherman and Ray Guillory that revealed something quite remarkable. The thalamus doesn't simply relay information to the cortex, right? It doesn't just go up there. It actually shapes how we experience reality. And their work, published in Functional Organization of Thalamo-cortical Circuits, demonstrated that thalamic neurons engage with what's called rhythmic bursting. And this means that they fire in very coordinated patterns that help create the unified nature of our conscious experience. And to further understand this, why this, these small little structures, when you have such a huge brain, why do these two, I think it's 38 million neurons combined of both of these, out of the 100 billion neurons in the brain, why is this small part what actually generates our conscious experience? Well, to understand that, we need to dive a little bit to the thalamus's architecture. So you can imagine that the structure is divided into very distinct nuclei, and they each have specific functions, but they're all working in harmony and concert together. So, for example, you have the lateral geniculate nucleus, which handles vision, and you have the medial geniculate nucleus, which processes auditory information, and the ventral posterior, which manages somatosensory input. And it's important to note that these are some of the basic things you'll learn if you watch any lecture on the thalamocortical system. It's that all cortical areas receive thalamic input, and virtually all information reaching the cortex must pass through the thalamus. And while that is also remarkable, let's talk about how they communicate with each other. So there was some work by Wolf Singer at the Frankfurt Institute of Advanced Studies, and that showed that these nuclei don't operate by themselves. They create what he calls temporal binding windows. They're very precise time frames during which different aspects of experiences are integrated into a coherent whole. And with that, it kind of helps us explain why we experience reality as a unified moment rather than fragmented pieces of sensory information, like I said. Now, to really get into the details of that a little bit, we have to talk about the three major types of nuclei. So we have first order nuclei, higher order, and non-specific nuclei. And so we have the first order nuclei, and these are also called relay nuclei, and they receive primary driving input from sensory organs. About 10 to 15% of it is the peripheral sensory organs, and then the rest is from the cortex, and all of those are subcortical systems. And it serves as the initial relay station, practically for sensory information. And so it includes structures like the lateral geniculate nucleus, the ventral posterior nucleus, and the medial geniculate nucleus. And Murray Sherman was actually the guy who showed through his research that it's 10% input from the peripheral sensory organs and the cortical feedback. And like the lateral geniculate nucleus, for instance, it received direct input from the retinal ganglion cells with layers 1 to 2 handling color, while layers 3 to 6 process motion and contrast. And so that's pretty much what the first order nuclei do. They're kind of that first contact, then relay the rest of the information. And then you have the higher order nuclei. And these receive primary input from cortical layer 5. I'm pretty sure there are 6 of them. So it's cortical layer 5, it's quite down there in that. But it mediates communication between different cortical areas through the cortico-thalamo-cortical system. That's what they call it. But I'll probably just call it the CTC pathway for short, because that's a little easier. Like, try to say that 3 times fast. Cortico-thalamo-cortical pathways, actually, it's kind of easy. Kind of rolls off the tongue a little bit, I will say. But so this includes the pulvinar and the medial dorsal nuclei, and they operate at a very integrative level. So like the pulvinar, which is like the largest of all thalamic nuclei, which contains approximately 6 million neurons, which is actually a pretty big chunk that this one nucleus contains that, because it's about like, I don't know, maybe like 20, 22 million neurons in the entirety of the thalamus. And the thalamus contains like 50 to 60 distinct nuclei. So this one guy is really doing a lot. So the pulvinar is quite large, but it's divided also into 4 distinct subregions. So there was some research by Robert Desmond at MIT that demonstrated that these nuclei don't receive any direct sensory input, right? They mediate communication between different cortical areas, and they create the CTC pathways. And so like what's interesting is actually, what I thought was really interesting is the medial dorsal nucleus, and it has dense connections to the prefrontal cortex and plays a very crucial role in working memory and executive function. And if you don't know what working memory is specifically, it's the part of short-term memory that is connected with the immediate conscious perceptual and linguistic processing. So, and what's also immediate? Our consciousness. Very interesting, I will say. So, yeah, that's pretty much the higher order nuclei. And then lastly but not least, we have the nonspecific nuclei. And the reason why I'm not really going into any detail about the 50 to 60 nuclei is because we'd be here all week. And honestly, we actually don't know a lot about each distinct nuclei and its specific functions. It's actually there's very little, but we do know this much, which is very nice because it's really quite the fascinating structure. And so the nonspecific nuclei, right? The last but not least, that's for sure. Because this includes the intralaminar group and the midline nuclei, and they form what is called the thalamic matrix. Ooh. And these nuclei project widely across the cortex, and rather than to specific regions, they project everywhere, right? And Rodolfo Linnaeus's research revealed that these nuclei fire in rhythmic bursts at around 40 hertz, creating what he termed the temporal binding necessary for consciousness. And, you know, I would think that there is a fairly large consensus that it's really within the thalamus that is what's generating our conscious experience. I know there are some people who believe that it starts in the brainstem. I think that there's a really close connection. I know that there's a lot of, I know like from an IIT standpoint, like integrated information theory, the thalamus by far has the most phi value, the most integrated integrated mathematical or network of connections that lead to the most amount of integrated information. And I think so, and I think the brainstem also has fairly high amount. So, but I do think it's mainly the thalamus. I would agree with them. But he revealed that the non-specific nuclei, they fire in a rhythmic burst, right?
Real fast, you said they fire at 40 hertz.
Gamma.
That's gamma, right?
Yes. Yeah. So they fire at the gamma frequencies. And, so, and that's pretty much it for the non-specific nuclei. But actually, I will say, hold on real quick. So the central median nucleus in this non-specific nuclei is part of the interlaminar group and contains only 100,000 neurons, but it plays a very, very crucial role in attention and arousal as well. So when you get aroused, that's thanks to your central median nuclei. So you can thank them for that, as well as, the ability for attention.
Thank you, central median nuclei.
You're the best. Seriously. But, it's very interesting because these three types of nuclei interact very well together. So there was Nikola Halassa at MIT who demonstrated that they create distinct but interconnected networks that operate at different temporal frequencies. And so the first order nuclei typically fire at gamma frequencies, 30 to 100, and higher order at beta frequencies, which is 15 to 30. And non-specific nuclei, because I think they can kind of get away with it, they fire at both gamma and theta frequencies, when theta is 4 to 8 hertz. Theta waves, nice. Yes. And he terms this the temporally multiplexed information channels. Sounds kind of like a nerd in my opinion, but kind of makes sense. But pretty much these allow different types of information to be processed simultaneously without any interference. And so, lastly but not least, one of the most important parts. So you know how I said that these are like walnut-like structures? There's actually a skin-like nucleus. Kind of, you can think of it as like the skin of the walnut. You can kind of shave it off and see, kind of the good stuff. But then there's, that color, that brownish color to it, right? It's the skin of it. And that is the reticular nucleus. And it's a thin sheet of GABAergic neurons that surround the thalamus and act as a filter for all these nuclei. And there's some research by Kari Mikalonen that showed that it can modulate thalamic activity within milliseconds. So about the same time that the brain experiences when we feel like deja vu, it's that error correction of your predictions that then kind of takes you back in time in a way for you to experience it again. And that all happens within milliseconds. It's kind of like it's the exact same time frame. And it effectively controls what information reaches consciousness and which doesn't. And it contains like
so these are your attention mechanisms, is what you're talking about.
Yeah, pretty much your attention mechanisms. So like you have like your central median nucleus that is practically it's modulating all of the thalamic activity.
Sounds a lot like Sounds a lot like machine learning attention and autoencoder combined, where you take a bunch of different input data, and then through autoencoder layers, you distill it down to its most important features, which then get processed through, might get processed through an attention layer, which determines which of those features it needs to pay attention to at any given time.
No, it's exactly like that. It's like a hierarchical value structure that then mediates what information is the most important. So, like as I'm talking to you right now, there are very hyper specific things that I'm fully focusing on with you. I'm focusing on, your eyes currently that I'm looking at, the way I'm talking, your beautiful brown eyes. And, me moving my hands in the secondary, you like kind of moving your hand, or maybe the fact that I just drank a Zevia, those types of things. And then it kind of processed through a hierarchical relevance. And then the rest of it pretty much gets completely discarded.
Yeah.
And all of this is done by your reticular nucleus that then allows for the rest of the thalamic nuclei to kind of do their thing, and then it regulates it. And so that's really the entirety, for the most part, a very brief and general, but very, I would say, thorough overview of kind of how the thalamus works, and how it kind of creates the generative model that is pretty much a part of every specific mode of information, your senses, and your experience.
It's interesting that when we consider how much of our reality is likely determined by our overlapped attention mechanisms and information processing mechanisms in our brains, like the areas that we all overlap. If we consider the outcropping, so you might think, for instance, if I were to record, let's talk about like audio attention. If I were to record a sound with microphone, you're like, well, you have all the information there when you record it, but we consider the fact that when playing that back, we're still processing it through our attention mechanisms. And then we also consider the fact that a human being built the microphone with specific information gathering purposes geared towards the information that they want to be able to record, the important information to them to record, which is dictated by our attention mechanisms. That microphone is even going to be biased towards our attention mechanisms. So it'd be interesting to experience a world with either no attention mechanism or a different attention mechanism than humans have. Like maybe the attention mechanisms that dogs have. Like that would be an interesting thing.
With like human brain complexity.
Right. Like it would just be an interesting thing to experience, because what kind of different kinds of data would you be picking up on and processing, and how would that form relevance, in your brain, and what associations would you create as a result of having different filters? So that is fascinating. Yeah. I should have chosen to cover machine learning's attention mechanism this week. That would have been
maybe next week. Give them something that'll.
Yeah. Speaking of which, the topic that I'm going to cover here is it's a specific type of LSTM layer in machine learning, and it's less well known because it is built on a specific branch of probability, and is not applicable, not necessary for all tasks, and it was also more recently developed, and it is called the Bayesian LSTM. And for those that don't know, I'm going to quickly go over the mechanics of an LSTM so that we kind of understand how an LSTM processes data on a base level. An LSTM, we can think of as being a context loop, a memory-based context loop. So when LSTMs are trained for various tasks, one of which is you can train them for everything from translation to sentence prediction, to audio processing abilities and audio translation and whatnot. And they excel at sequence tasks where one thing comes after the other that needs to be taken in context of the whole. And they do that because they create a prediction as their output, which is then fed back into the network, and as the second piece of data is fed into the network. So it's basically like feeding its previous context like back in as the entire sequence of information is being processed, and it trains its memory elements to hold on to relevant information in the sequence as it's being processed. Yeah. So it learns to pick out the relevant pieces of information given any specific context that's coming in, as it's processing these different frames. So we consider the data that goes into an LSTM is generally in the following format. It's generally, you have a sequence of time steps, each with their own features. So we have a sequence which represents an overarching snippet of time. We have a time step, which is a frame in which that time was captured. And that time step contains features that were extracted. So features meaning something of note. A feature could be a word. It could be like a word vector, but it could be a word. It could be a collection of extracted frequencies from audio. But anyway, that is those times. A time step, single time step with features is fed into the model. It processes it, outputs, brings it back around, and then it has internal memory mechanisms, like they're called gates. But you have a remember gate, a forget gate, and I think a reset gate. I think that's correct, because there's a couple different types of looping models, each with their own types of gates, but I think that's the one that the LSTMs have. They have a memory, forget, and reset, and those gates are that determine those things, like what is remembered from the data that it's being trained on, and what's forgotten from that, like what's important, what's not important, kind of a thing. And so they are really good at taking things in context. And if I say any given sentence, if I say the word I, what is the next thing that you think I'm going to say after that? After I?
Want, will.
There you go. Those are potential outputs for the LSTM for what it's predicting that next step is going to be. So we have the actual output might be am. I am. We feed that back around into the LSTM. Okay, well, what's the next one? What does it think the next step is going to be there? What do you think the next one is going to be?
A.
What is another one? Give me another one.
B. Super.
And the next one might be hungry. I am hungry, but its job is to take a sequence and come up with options for what it thinks the next thing is going to be there. And so that thing that you just did, where you're like coming up with options of like what could be next after this, that's the
most likely.
That's the LSTM's job. And so a Bayesian LSTM is interesting because it expands our capabilities with LSTMs by essentially, the technical way of putting this is it allows us to create a probability distribution for our outputs. The easier way of understanding it is to say that it allows us to predict how likely any given outcome is. And so we'll take that sentence example. When I'm predicting the next word, what a Bayesian LSTM allows is for us to take those different candidates, those different output predictions. Like, for instance, in the sentence, the next options might be go, scream, take. There are different candidates, and each one of those has its own probability attached to it that, given the context, is likely to occur next. So it learns to kind of calculate these exact probabilities for you, so you can see the likeliest scenario. And the reason that is significant is that it allows us to now make decisions on something based on the probabilities distribution there. So if everything is fairly equal in its distribution, there's not one answer that's significantly higher, has a significantly higher likelihood. We might choose to do something different than if it had one that was really high likelihood. And so understanding how accurate different predictions, or how likely certain predictions are going to be, has a lot of really useful potential applications there. We can think of it kind of like a simplified analogy for this. Might be like we can think of the kernels which are matrices. They're number matrices for neurons. Like the kernels, we can think of the kernels as, from the Bayesian part of the model, as almost like experts in specific topics. And the Bayesian process as sampling a random number of that group of experts on a topic, each with their own specific biases and history and background and point of view, sampling a random number of those experts and asking them to come to a conclusion on what they think the outcome of a scenario is going to be. Then we take another sample, maybe of those experts, and ask them to come up with a conclusion. We start looking at this probability distribution from these random samples that we're taking of experts, and seeing what, like, combining that together almost by method of the mean of value, to come up with a most accurate prediction. And so the Bayesian model is something that can basically give us our options, so to speak. Like, it's not just going to tell you what it thinks the most likely next scenario is. It's going to tell you what the candidates were and how close that contest was.
Mm-hmm. And could that information be then reinforced back into the model for, let's say, another, probability problem set?
Oh yeah, like the Bayesian kernels, what they do, they kind of almost act like a detective that has an initial gut feeling about something. Then as it gets its data and starts refining that gut feeling of okay, now given this next piece of information, I think we're heading in this direction now, and this one option is less likely. And so it kind of like starts forming these information-based gut feelings that gradually get reinforced. And that's actually it's interesting because that's kind of how the mechanics of a full-on Bayesian model works. It has two kernels, which again are matrices of numbers, a prior kernel and a posterior kernel. And the prior kernel provides the initial gut feeling without the additional information. The posterior kernel is a refined version of the prior kernel that has made adjustments to its probability based on the new information provided. Now that posterior kernel moves back and becomes the prior kernel. So that posterior kernel is always becoming the prior kernel with the next piece of information, and it's gradually getting refined. That's that gut feeling that's getting refined,
Mm-hmm.
So it's very, very interesting in its mechanics, and you can create the one that I've been working on recently is kind of a simplified version of the Bayesian LSTM that utilizes something unique in that it utilizes what's called a dropout layer, which is normally something that is added to a model to prevent overfitting. So over-tuning to a specific data type, meaning that if you have a lot of some specific thing in your data, you don't want it to get over-tuned to that and now only predict that, because you want it to be fairly well-distributed and predictable model. And so to prevent overfitting, we use dropout, which randomly drops out neurons during the training process and then adds them back in later and then drops out different sets of neurons. So it makes sure no single neuron gets overtuned.
Yeah.
Right. Mm-hmm. And normally that's turned off during inference, which is when the model is used outside of the context of training. So when we're not training it anymore and we release it for production where people can utilize it and play it online or whatever it is, during inference, those are usually turned off. However, there's a really cool variant of the Bayesian LSTM that uses a dropout layer to create the random sampling element for the neurons. So it will feed the information with a dropout layer through the model with a dropout layer, giving a random sampled output. Then we'll feed the information through again, the exact same information again, but this time with a different iteration of the dropout layer, meaning different neurons were dropped out, giving us a different output. And we do that again and again. And then we average those predictions together. And that gives us a really, really good idea. Calculating the variance in the mean of those outputs gives us a very good idea of the uncertainty in our likely prediction that we make there. Mm-hmm. And that what makes this model and method unique is that dropout layer is kept on even during inference. necessary to the way that model functions. And so, to my knowledge, dropout layers before that, dropout layers were never or very, very rarely left on during inference. But in this case, it's absolutely necessary.
They can be.
Yeah.
Awesome.
Yeah.
Man, these, like, I'm surprised this isn't, is there a reason why this is kind of more of like a really like niche, like not many people know about this model? Because it seems very, very useful.
It really does. Most, I guess, functional tasks for people, it's not necessary to know the probability of any given output. The only scenario that I could see in current machine learning context, the only scenario I could see that being something that is incredibly applicable is A, for human review, so that humans can know the probabilities of its output, or B, in the context of an addition to a reinforcement learning model. Because what those probabilities help inform is action. They help inform what action to take on the data. And deep learning models are not designed to decide actions. They're designed to make predictions on data. And so in the context of feeding that data into a reinforcement learning model, reinforcement learning models are designed specifically with the goal of taking actions. If you feed those probabilities into the model, it now has much better idea of the actionable data within there. And that's the same reason why it's useful to us as human reviewers, were we to like utilize that, is that informs our actions.
Mm-hmm.
And so the reason why it's not well known is because in deep learning context, it doesn't have much utility solely in deep learning. And deep learning right now is the main area of machine learning that is the region of machine learning that most developers fall under, and kind of the areas that have been booming. Reinforcement learning is much less studied and is much less developed than deep learning, because of sometimes how unpredictable those and hard to train those networks can be, and the somewhat limited application of reinforcement learning. But part of that problem is because of the lack of development, and part of the problem also is because of the lack of the proper data for these models, which can be provided by a Bayesian LSTM.
Yeah,
that's the data that is needed to connect those two machine learning architectures together, is the one that's output by the Bayesian.
This is the missing piece.
It's the key. To making those a lot more functional. So anyway, that's that is the Bayesian LSTM, and
I'll learn it.
Definitely worth looking into. It's a lot of the same processes that go on in the Bayesian LSTM are the ones that we use in our own cognitive function, determining probabilities and whatnot. And so, we are going to. I think we're going to close out here because we've been going for a while now.
Over 2 hours. Pretty well.
2 hours and 30 minutes actually. Yeah, it's quite a while.
Good podcast though.
Yeah. Next time, we may be going over as our nootropic. We may be going over compound 7P, and we may have our new cameras, a new setup in by that time. We'll see. And I'm not sure. Are there any other updates other than that?
I'm Not sure. I think those are all the updates necessary for them to know. I mean, obviously, you'll get a lot of good, rich information next week, as well as I think up a neuroscience topic.
Yes.
So I got a couple of ideas floating around, but I'm just gonna, allow my whims to choose.
Someday when we actually have an audience,
we'll put a little more effort into it.
I was going to say, when we actually have an audience, we can ask them,
what they want,
what topics they would like us to cover, and that might help us make that decision.
That's true.
But yeah, thank you guys for watching. We're going to close there, and we will see you guys next week.
Peace.
See you guys then.